The objective or agenda for the 2 days webinar is that you're going to cover data visualization using Python and how to begin. Everything will be explained. How to begin, that's the main one. How, when to use. How to begin and when to use. Okay, this will be covered. About myself, so my name is Nitish and I'm working as a technical specialist in a company, in a tech company, and it's located in Noida for now. And the skills that I'm working on day-to-day activities is related to Python, machine learning. ML stands for machine learning. DL stands for deep learning. We have Tableau, a powerful visualization package that we have in the market. Along with that, I read R, images, image processing is my part. NLP is natural language processing. These key activities, along with how to get the data. So I have to use Hive for that. Hive, or you can enter SQL. How to extract the database from the database. How to extract data from the databases. So it's like a more of day-to-day activities for me, as well as I lead a team of 6 people out there as of now, in which I am taking further with the models part and the R&D over here, building the product. So it's some related activities I have to perform. My role over here is that to describe you, to help you on the data visualization with Python. Not about teaching Python, taking the Python as the prerequisite for this webinar. And believe me, when you start seeing the concepts, how we're writing the command, you will be able to grasp it. It's not a rocket science. Try to understand little by little the codes that I'm going to write it down. But majority of the code, since it is related to data visualization and packages out there, so you will be able to grasp the concept of that also. I hope I am clear, and are we good to go? Those who are asking me where the contents will be uploaded, so for that you can ask the LearnBay team also. The video is already recording. This video will be available on the YouTube by Monday or Tuesday at maximum. And the contents that we are going to cover, it will be again available to you by tomorrow itself after the session. And you can take it from the, or either from the LearnBay LinkedIn page. The access will be given, the link will be shared with all of you by the end. As of now, those who are looking forward to practice along with me, I request you to go to this link, and I'm sharing the link in the chat box also. Can you see the link in the chat box? So those who are looking forward to practice along with me, they can use this link to retrieve the dataset. I've given the access for all of you. Just directly download it. Now, I'm going to begin with this new topic. And for every new topic, I need to have an understanding of my audience. Before I start, any specific question you have, please write in the chat box. Any specific? Okay. Now, to begin, what all you need? What are the requirements over here? One is, all of you have the dataset which I am sharing over here. This is the link. Second is a Python software. Those who are well experienced, they must be having some software. I will be using a Jupyter notebook. Jupyter Notebook for it. Okay, so Jupyter Notebook. Okay, for that also now I am sharing the link. Yes, guys, this will be available on YouTube also. Okay, so there is one more link over here. This is for Anaconda. Anaconda installation steps. I'm sharing with all of you in the chat box. Everything is available in the chat box, guys. And third is, so dataset link is given to you, Python software that I'm going to use. Now, what are the steps over here? Let us check it out, the steps. Those who have any software, they are good to go. Those who don't have, they can use Anaconda, or they can directly have a Google account and open Google Colab. Google Colab is also giving you a platform to practice Python. So either you have some software, maybe those who know, only for them I'm saying. If you have PyCharm, Spider, Idle, your VS Code, your Jupyter or Anaconda, that's okay. All are local system. But the next is Google Colab. Google Colab is using its server to provide you help to practice Python. I don't know about your system. Your systems can be having 2 GB, 4 GB RAM, or hard disk as maybe 500 GB also, 1000 GB also can be there. But what happens about Google Colab now? They are providing their own server, and they are all providing their own RAM and your hard disk also. So you just can keep the data over there. So you can use Google Colab. It's but you have to be online. You have to have internet connectivity for it. So Google Colab over here. Okay, Stuti, you can work on Kaggle also. They are providing you platform. You just have to upload the dataset which I have given to you over there. Okay. So connecting to the runtime enable. Okay. This is a Google Colab which is given to you, or you can install Anaconda. After you have installed Anaconda, by performing the same steps, you will be able to open from start menu Jupyter Notebook. It's a part of Anaconda environment. So Jupyter. First time, those who are using Jupyter Notebook, make sure that this dialog box, this CMD prompt that it opens on Windows or Mac, please don't close it, because this is the intermediator that is going to run Python code for you. If you close it, it will not be able to understand. The system will not be able to understand the Python code, and you have to again close it and open it again. So don't close this, just minimize it. So first time when you open the Jupyter Notebook from the start menu, a dialog box will open, just minimize it. And on some browser, maybe your Firefox, Safari, Chrome, any software, over there na, you will have your home page. This is a Jupyter home page. If for the next 3, 4, 5 minutes, very first time, the system is not able to go to any browser, request you to please copy this link. Copy any one link and paste in your particular browser. First time when you have opened by copying the link and opening in some browser, it will be able to detect the next time what is the relevant software you're working on. And via Jupyter Notebook homepage, you can see a couple of folder names are available. You can create a folder anywhere. I'm keeping everything on my desktop for now, where I've kept the file shopping products CSV. This file I have kept. I will be using this file for your particular analysis or visualization. Okay. So now again, I'm repeating what I'm doing. Let's close everything. Close everything for now. Those who have installed Anaconda or installing, it is a heavy software, 500 MB. It will take time. So by the time you will be successfully installing it, the session will be completed. Okay. So it's a good activity. You track down what all we are doing and how to perform. By today evening, you can install at your end and repeat the same task. And tomorrow we are going to have a hands-on on different activities. Moving forward, assumption again, there is only single assumption. You have some Python software. Use any software. I'm using Jupyter Notebook. From the start menu, open Jupyter. A dialog box will open. Just minimize it. It is automatically going to open on some browser. So I'm sharing the link again in the chat box. Please go through that. Okay, from this home page, select the desktop, and over here, I'm going to create the very first Python file. So go to new, and you will see Python over there. You will see the word Python over there. Now under there, select Python. This is the home page on which you will all be working. Done. So this is day one. Now, what is the Jupyter Notebook and how to use it? Let's take another 5 minutes for this concept, and then we'll begin our journey. So in this Jupyter Notebook, what all rectangles you're seeing now, these are the codes where I can run the Python code. Yes, you can use VS Code also, Divnesh. So Python code, like I can print something, 45 minus 3. It is going to give you the answer right over here. I can write another code. Let's say string name is given to you, some dummy string, and I like to capitalize it. I can convert the entire string to uppercase. I can take the entire string to title also. That is, every word inside the string shall be first letter should be capital and the other should be lowercase. So there are some activities you can perform in this code cell. These are all Python codes I'm writing. So these rectangle boxes, you can write the code, and when I'm writing the code now, for each of the cell, you will see the word code written over there. So this cells can be used for writing the code as well as to display the important information. Information also I can display here. I can follow some activities over here. I can use it for passing a passage, some good passage, what you have written or what I've written over there. Requirements. These are requirements I can also write down, and data set also. I can pass this thing, but in this scenario, it is not a code, it is an information. From the Jupyter notebook, we have a feature that you can convert this code cell in the same page to markdown. Now, this is the information that I'm providing with all of you. What is the Python software you require, and where is the data set, where is the Python software. And in this information, it is not a code, it's just for saving some information in the code itself. In Jupyter Notebook, it's a type of notebook. Like you have Notepad, you have notebook over here. This notebook can have Python code also, as well as it can have some information also. This cell on the bottom, you can check it out, it is called as code, whereas the above cell information is called as markdown. So under markdown, you can write down any text. It will not hamper your code. If I run it, you can see it's nothing happen. Whereas if I'm running above, I can get some output out there. How I am running? Cell on the Jupyter, you have to write down. Shortcut is Control plus Enter. So I'm doing Control Enter. You can see some number is incrementing on the left side. That number says that from the starting of the session, since I've opened a Jupyter notebook, this is the 33rd time I'm running some code. Any code, but this is the 33rd time I'm running something. 34th, 35. So since the starting of the session, 46th line or 46th instance at what I have run, this is the code I have run. So I'm going to write the codes over here. There is no hard and fast rule that you have to write the complete code inside a single cell. You can break down into different cells also. But if it's a method or class, it is advisable to write in a single cell, or else it will be an error. Okay, so is the basics clear to all of you? Okay. Not able to understand your point, Nikita. What information you need to import? Mhm. So it's unusual traffic here. Actually, a lot of people are using it. So that might be possible. The link is not working, but the data is already uploaded over there. And same for this. I don't know where you have shared it, but Anaconda for now you can install it. But let's see. Just log in with your part and you will be able to access it. What's subheading, Nikita? So in Python basics, we have something called as comments. I'm using this as a comment. Comment is used by the developers just to save the information for themselves. It does not execute anything. If I run it, nothing happens. But when I write somewhere that print some 71 into 3, that will be given the output. Yes, Mohammad Arfat, you can write anywhere. Python code will not change. Python code will be the same. Okay. Nikita, there is unusual traffic. I think the link have been shared to many participants out there. So I think maybe because of that, you're not able to download. But it will be given to you by the LearnBay team and available on their LinkedIn page. So go and download from that also. Okay, let's start. So in Python, there are certain packages. Now, what is a package? Package is something, if I say a number is given to you, number as 100, and I ask you some activity that print square of a number. We can write a normal Python program to get a square of a number, or to get square root by writing 0.5, because 1 by 2 is nothing but 0.5. So I get the square root of something. Or you can provide me, some operation I'm doing that divide the number by number divide by 6. This is the operation answer, but I want the integer parts, that is 16 I want. So I can write here int of this to get the output, to typecast it to int. Then further you can make a logic for it. Exponential, I cannot do it directly. You need to have the value of e. E is 2.71. E is 2.71. So by getting this conceptual clarity, I can get the exponential power of something else. So e to the power 3, e to the power 4, I can get it down. Print e to the power 3 or e to the power 2. I can get those answers also. And then there is some package to make your job easier. This package is math. So math is, now the same number is given to me. Let's say num I write down this time as 100. And math says I can get you the square of something. Square root of something. So I can use a math. And here I get same 10.0 as I was getting above. I can ask my math to get there is an operation you're performing on number, and I want to get the integer part of it. I can write over here floor value of operation, that is 16, which I was getting over there. And similarly, e is given to us 2.71, and I like to have exponential value of something. So print exponential value of e to the power 2, e to the power 3, and you can see there are similar answers as I have done reverse here. Okay, 3, 2. You get similar answers I'm getting over there. 2.7, some long floating number is there which I don't remember. And power you can also get. So I would like to get the power of number by 2. Here is your 1000 point something. So there is some package to make your job easier. Along with these, which you can do with the help of normal operations also by applying some logic. you can do a lot of operation like in the math you can perform cosine, sine, these trigonometric operations. You can go with product, pi value, and log, gamma. There are so many things you can perform with the help of math. So similar to that, there is something called as packages that makes your job easier while performing data activity or data analysis. Anything related to data that is working on two-dimensional data set. This is my CSV file kept here. I love to work on this anywhere CSV file. What I can do? So there is a package called as pandas, with the help of which you can read and complete data manipulation. There is a package called as NumPy to perform mathematical operations. Like you have math, you have NumPy also to perform enhanced mathematical operations. Math cannot do linear algebra, but your NumPy can perform it. Math cannot do Fourier transform, but your NumPy can perform it. So such operations I can perform with NumPy. There is a package called as Matplotlib that is used for data visualization, which we will be using. And this is the first one that came in the market. Then you have Seaborn, which is again data visualization, and that is the second one. And it is built on Matplotlib. Built on Matplotlib. Okay. So these are the 4 packages you need to install also on your system. These 4 packages, how to install? If you are using Jupyter Notebook only, then kindly run this command. Pip install that package name. That is the syntax. If it is already installed, it will come requirement already satisfied, or else it is going to install on your system. Okay. So it's already installed for me. So you can go with writing the same words, but in lower cases. Pandas also, Matplotlib also, Seaborn also. This is a syntax to install any package. Once you have installed the packages, kindly import the packages. Import the packages. Why import is required? So there is no inbuilt operation of exp, exponential or floor. They are all taken it from the math package. So we have to call the package into this live session, into this live active Python session you're working on. Hence, to work on data analysis, data visualization, what all packages are required is import NumPy as NP. NP is a universal abbreviation we use for NumPy. Today we are going to focus on Matplotlib PLT command. So these 3 packages installed. Tomorrow we'll talk about Seaborn, not today. So my data set is available in the same directory where I'm working, where is my day one Jupyter file is there, my shopping product.csv is also present over there. So I'm going to write down pandas, that is pd dot read csv. Over here mention the file name along with the extension, and we are going to use the df over here to check it out how the data set looks. So you can check it out. There are some shopping products are kept over here. Where we have product ID associated with all of them. And then we have product name. So whenever you go for any product, what do you see on mobile? But is it as of now it's on desktop? What all you see? You see this product ID is for the backend. Don't worry as of now. Product ID you might not see. Then we have product name. So Ben Houston, Scott International, Rods, and going below. So the very first word that you see is the product name over there. Title, that is a title. What is a title? The next thing is about the product as a brand. Brand we can see, but I think over here we can't see. So it's just this small product name is available to us. So normally discussing. Whenever you open anything on any shopping website, let's open the Myntra also for shopping. What do we see over here? First thing we see is brand name. There is a brand name later. Then we have the product name. Then we have brand and product. Similar, I think on Amazon also. First brand is coming, then product name is coming up. So we have a brand name and we have a product name associated. Gender, these are details over there. So we have gender, price, and number of images also associated. We can have gender not mentioned, but it is specific for men or women. Colors also we are associated. 10 colors or 4 colors, and now how many images are there, that is also we are associated with here for all the platforms that we see. Then we have description. Actually description comes when you click on something. So I click on this, suppose t-shirt, you get the description over here, get the description, product details, these are descriptions available. So you can see product description is a lot huge, people write it down for it. Similar to Amazon, if I click it somewhere on US Polo, here is the description available, what's all going on, or product details. That is a description for us. And then you have the color, on which color it is available. Now when you see this type of data set, a shopping data set, and I like to ask you some of the obvious questions. Let's say just write yes or no if you think that is important or not. Is it important when I open either Myntra or this fashion Amazon for any of such products? Is it important to write the brand name in the product name under the product title or product, something you can understand under the product? Is it important to have a brand name over there? Do you agree? If you see a brand name, there is a higher chance for buying it. It's like a general observance. Is it a good chance if people see the brand name in the product title, they will click on it and they will buy it?
Okay. And instead of our product title, if I write the same thing under the description, if I write down, will you go to the description section to check it out? Everyone is focused on the first impression, right? So I think our thoughts match over here. And is it a higher chance to have a look of more pictures? That is, more pictures are there. There is a higher chance of sale. Okay. And what we have, color. Does the color also play an important role while you're looking at the pictures? Clear? Okay, everyone agree. So we need to perform a data visualization in this form to draw the analysis. What you can learn, this is a general things, what you have done. Why not to support your analysis, support your hypothesis, what you have observed in real life? By God gift, everyone are clear of the hypothesis, what you see in your real life. You get the experience. You just have to support your experience. So we use the machine learning over here to support it, whether there is a higher chance of that or not. We use the normal pandas and data visualization to support our hypothesis that when we are thinking more number of images, is it so that maximum products over there on average are we having maximum number of images or not? On average, what is the price range? Do you agree that people there will be higher chance of product buyout between the range of 0 to 1000 as compared to 0 to 5000? Product less than 1000, product more than 1000, let's say, if I bifurcate, there's a higher chance the people are going to buy less than 1000 more products as compared to more than thousands. So that is the distribution of price. You'll understand this also using our data visualization package. And then product brand name, we will also consider that, yeah, there are so many product brands. Let us see what are their price distribution if we want. And also let us see their with respect to product brand, what is the number of images they are looking forward. Maybe a new person. So as an e-commerce company, when you're sitting back and you have to help hundreds of merchants who are onboarding on the particular platform, you can help them. Then what is the average number of images you should take it up for the product? What is the best color possible for the product? So that we can help other merchants also. This is a small objective here. Is that clear what we are trying to accomplish by this data set? To help other merchants, other new persons out there, what is the new number of images they can keep, what is the price range, the color that they should keep up, and the gender, the target audience, if they are able to get it out. So for that gender, what is the color they like or not like? Okay, so there are hundreds of such factors you can draw from this small data set, and it's a huge data set. You can see it's over 12,000 records we have. So I think it can help you a lot. Is the objective clear to all of you? So we have extracted the data set with the help of pandas over here, shopping products. Okay, let's do it now. Shopping products given to you. Now I will be using data df.head command. Actually, what happens when you have some data set given to you and you like to perform small changes? Every time I will not be using so many records to check it out, whether the changes have been done, and after the changes, how the data set looks, how we have restructured the data set. I will be, like we perform any changes, I like to keep a check on top 5 records or top records. So some generic Python pandas commands are head, default top 5 records. So I can get default top 5 records. But if I do with 3 here, I can get top 3 records also. I can get top 1 record also, top 10 records also. 25 records I can get out. So there are 25 records from the top. I can get anything. And those who are using any Python software, I request you to please write down the same command under print df.head, because over there you will be displaying in a different window. In Jupyter Notebook, the answers are displayed just in the same window. So there is no requirement for that. I can directly run this command. Like we have tail, head. Similar to that, now we have tail also. To look at the bottom records. These are the bottom records that we have. Okay. And let us understand the description also of it, statistical description. For this, we can use df.describe. And over here, you can have a statistical description. By default, it's for all numerical columns. It's all for numerical columns. If you want to include all of them, you write down include. Very simple English word. Include all. Now I have the information for all the columns. Those who are categorical, for them numerical values will be NA. So we have product name, product brand, they are categorical. For them, mean, median does not support. So we have NA over there. And vice versa. Those who are NA, we have, those who are numbers, for them categoricals are NA. Okay. So description tells you about the total records it has. For categorical things, it tells you that what are the top record that is having the highest frequency and how many records it has supporting it. So we have over 70 records for Park, Men Blue, same product range. We have Indian Terrain as the brand, 971 records are there. Women 5134 records are there. They are the highest one. And under your numbers, we can check it out. Mean, median, mod, 50 percentile is the median. Mod we don't have. Minimum and maximum. So under price, the minimum price is 90 rupees that is uploaded for there. And the maximum price that is uploaded is 63,000. Gosh, I don't know what is the product. 63,000, the clothing brand. Wow. Whereas the mean price, you can check it out, for the 12,000 over 12,500 products that we have, the average is 1,400 only. That is product as high as 63,000 is also there. But because the count is so much that if we divide by 12510, we are going to get 1454. That means majority of the records are going to be belonging between 0 to 2,000 only. Majority of the records. And majority of the images is around 5 images. So rough information that you can draw over here. The rest of the Python commands I will tell you, the pandas command that might be required. Data visualization using matplotlib. Going from the basics again, let us understand what we have for the matplotlib. What is the structure? So we have PLT as the command that I have derived above. Import matplotlib as PLT. The syntax is plt.plot. This is the actually chart name, you can say. What is the chart name you're looking forward? I'll come back to this one again. plt.xlabel. What is the X label you like to have? Y label. What is the title you like to give for the chart? And plt.show to display the chart. This is the generic syntax for any plot. So if I do na chart, let's say I would like to plot. I am taking my x1 as sorry square to get the log value somewhere. So np dot log value of x1 and exponential of x1. So what is this all about? So my print x1 is equal to x1 y1 y2 y3. y3. np dot sqrt Okay, so what I've done, I've taken a x1 from the range 1 to 21. This is the x1. Secondly, I'm taking y1, which is nothing but x1 to the power 5. So you're getting exponential, oh sorry, you're getting power graph, polygraph. And y2 is actually log of something. So log of each element, log of 1, log of 2, log of 3. So it is giving you in this range, the values. Then we have your exponential e to the power. So what is e to the power 1, e to the power 2, and then going till e to the power 20. And finally, we have square root of all the numbers. So 4 things I have taken. I'm going to go one by one. Then I will combine all of them 4 in a single chart. So as per this basic plot, if I take only x1 and y1 in scenario, only x1, y1, it take it out. And this is the generic plot I copy. Using this syntax only, you can have all the charts. So I'm going to plot. The syntax is x and y. So x1, comma y1. X label, and this is the complete information. We have plotted between x1, y1 X label, Y label, and then title. That is how you can make a plot using matplotlib. I'm using a PLT. PLT I have drawn from the matplotlib command as PLT, matplotlib.pyplot as PLT. What else you can do over here? I can have colors also. I can have colors also. Marker also, I think you can keep it up. Marker is equal to 3. So some stars are there, or 4. So some type of marker you can also associate with. Then there is always a pattern for it. So I think 7, not available. D, diamond. So there are some markers you have to also search online. Some type of syntaxes are there. And now I like to, this is single plot. This is a single plot. What I have done for the single plot, again I'm repeating, I have taken X and Y. Between X and Y, this is a generic plotting method. We use a plt.plot or plt any chart name. Provide the syntax over here, what you like to keep on the X axis, Y axis. C is for color, marker is for this pattern. Then X label, Y label, title is for X1, X axis, Y axis, and title respectively. PLT show for showing the chart. You want to increase the figure size also. So we have something called as so 20 stands for width. I have increased the width of the entire chart. And this 6 stands for the height. So 20 is the width, 6 is the height. You can keep anything over here. I can write on, let's say 5, even 30. 5, 30. Smaller width, but higher height. Go with anything over here. What you think is desirable, what's comfortable for you. The 26 seems to be comfortable for me. I can get the entire chart in this single line. So this PLT figure helps you to give the area for the entire chart. Okay. Now suppose this region I'm highlighting like this. This is the region you have. This is the above chart region you have. Now in this above chart region, why not to break it down into 4 parts? Break it down into 4 parts. Let's say one is this is 0, 0. Then we have your star, 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 star. Or maybe I can have 2 charts for that, 2 regions, or I can further break it down into 4. Let's say I like to have this star. It's just representation demonstrating what type of figures you can break it down. This entire chart. You can have single figure over here. This is represented by X, or you can break it down 1 row, 2 columns. This is 1 row, 2 columns above one. This can be as one type of approach. 1 row, 2 columns, or you like to have 2 rows, 2 columns for this entire chart. This is split it into 2 rows, 2 columns. This entire chart is given into 2 by 2. Is that clear what I'm trying to highlight here? That you can split this region, entire chart area, into either 1 row, 2 column, 2 rows, 2 columns, or 1 column, 3 rows. Okay, 1 column, 3 rows.
So we can split the entire chart region into further subplots. This is called as subplots, which I'm trying to draw over here, giving a visual glimpse how it can work. This is what I was describing over there. Can you see? Either you can have 2 rows, 1 column, 1 row, 2 columns, or 2 rows, 3 columns. So we are splitting the entire chart area into these subplots. This is what I'm describing over here. If that is the way how you're looking forward, so simple is you should know at your mind how many subcharts you're looking forward. In your mind, you should have a clear figure how many subcharts you're looking forward. Now on the subcharts, you have to define the position number, that this is position number 1. How many I have? So subplot, I'll be using something. This will be total. We have 1 row, 2 columns. 1 row, 2 columns in this particular. And with respect to this 1 row, 2 columns, the next one is the second position number, and this is at the first position number. In this scenario, we have 2 rows, 2 columns. Two rows, 2 columns, and this is the first chart. 2 rows, 2 columns, and this is the second chart. 2 rows, 2 columns, this is the third number, and 2 rows, 2 columns, this is the fourth number. Is this point clear? How you can break it down the charts into multiple subplots? You at the back end, you just have to understand how many subplots you're looking forward, and then match. This will be subplot. It's 3 rows, 1 column, and then this is the first index. 3 rows, 1 column, second index, and 3 rows, 1 column, this is the third index. So this entire chart area will split it into 3. That is what we have to perform for these 4. I have my x1 versus y1, x1 versus y2, x1 versus y3, and x1 versus y4. What I'm looking forward, plt dot, first of all figure size if you want, but let's take it on the last. So plt dot subplot, I like to have 2 by 2, 2 rows, 2 columns. At first position number, I'm looking forward to do a plot of y1. Let's say color is equal to green, marker is equal to D. This is the information for first subplot. For second subplot, second position, I have x1 to y2. Change the color to magenta. Style of marker to 3, and this is y2, y2. On this subplot, second 2 rows, 2 columns, but third position number, I like to have my y3. Let's take it as yellow. Style as some 4. And final, 2 rows, 2 columns at fourth position. and you can see 4 types of charts are there. What I believe, yeah, it's very congested. And finally, those who are doing in other softwares, you have to use the plt.show. So I can see it's very congested. So for that, now we can increase the figure size. So figure size is a common command. You have to write it over top. And let's say figure size is 20, width 10 is the height. Yeah, it looks proper. So first one, x1 versus y1, x1 versus y2, x1 versus y3, and x1 versus y4. So you have 4 types of subplots over here. Is it clear now how to make subplots using matplotlib? The basics is clear to all of you? Okay. Now we would like to perform the similar activity, but on the data set. Now we're going to take a step forward with the data set information. Now, anytime when you are going with the analysis, guys, anytime when you're going with the analysis, make sure it always depends on the chart type, sorry, data type. The steps I can give it to you. The steps I can give it to you. So first is make a univariate. Over here, what we say, explore or study one column at a time. This is a time consuming process, guys. Believe me, it's a lot time consuming. But once you follow this process, now you have the in-depth idea. You will provide all the analysis points by yourself. Now over here, univariate analysis you have to perform. So if you know the data type of it, numerical or categorical, what do you think? What type of charts we can go with numerical? Anyone? Even Excel operations, those who are about to perform, this is a numerical. I keep it somewhere and I go with insert recommended charts. The Excel also shows you that it's a histogram. Yes, box plot you can also have histogram. So for single numerical, you can have a histogram that is study the distribution of it, or bar chart. In the categorical, if I keep a categorical thing now over a categorical like this gender, let's keep up. I like to have a study of gender, recommended charts. Automatically now Excel is telling you this is a new bar chart. So it gives you the count of something. It's a count or bar or pie chart you can also have. But the focus is that it's a count of unique values inside that particular. So count of unisex women or men, all of them you are able to have. It's about the count of all of them. And we can see women records a lot higher. So this is a univariate. No matter you're performing analysis in Python or Tableau, Power BI, Excel, any software, the steps will be same. Bivariate, explore 2 columns at a time. Now it is numerical versus numerical. You can have. So the numerical versus numerical. Any suggestions? Fantastic. You can have a correlation charts, or when I go numerical versus numerical over here, these two are suppose numerical. I pick it up and Excel insert. Can you see only scatter chart is the main thing coming up? Line chart can also be there numerical, but it's with date time we use it. So scatter. So understanding the data type is very important. For categorical, we can have bar chart, pie chart, we can have box plot. There are many charts available in this category. You will have maximum charts available in this category only. So the more charts we will cover, I will write the names right over there. Then we have multivariate. So explore more than 2 columns at a time. That is, and this is done on the basis of some categorical term. So let's say more than 2 columns, but it can be more than, let's say, I will try to cover as much as possible. Numerical versus categorical. Numerical versus numerical versus categorical, or it can be all numericals. Under this we have correlation charts, but above two will be same. Is it clear about the analysis, how we perform it? Now performing the same task of analysis using matplotlib can be a lot tough. That was the very first package that came in the market, giving you charts, colors, and everything information available. Then you have many elaborate tools. So matplot came into the market in 1999, whereas Seaborn, the next Python visualization package, it came into the market in 2000, I think 3 or 4. It was developed. Out of these 2 years, it came into the market. So it was built on matplotlib. We use this type of integration for Seaborn. Seaborn helps with easy process to complete the charts, as well as there are more charts. Colors and charts are there, but it is built on matplotlib. That means the syntax which I've written for matplotlib above, over here you're writing plt dot chart name. Now you write down, I'm using a SNS as the abbreviation here, so SNS dot chart name. Rest everything is same. For labeling, title, for displaying, everything it is dependent on matplotlib. Only for charts and other information we use Seaborn. So only the first 9 changes, the rest all are same. Okay. So what will happen now when I'm going with the visualization? I cannot run away with the analysis also. Visualization alone will help me out with the solutions. But how to get to the visualization, I have to depend on some Python commands to get it. So I'll be using some pandas query also side by side. Pandas query groups. Pandas query groups will be required side by side to display the results and every other attribute. Apart from that, I'll be using Seaborn for visualization. in this webinar. In classes, we cover the entire thing about Matplot, then move with the Seaborn. I don't have the time here. And yeah, these two things will be used side by side. Okay. NumPy, again, if it is required in my NumPy, these operations, then I will perform it. Is that clear to all of you? Okay, great. So we are going to cover all these steps, how to do it. It is going to take a lot of time. And on the top of it, I will also tell you that how to go with the in-depth analysis by making some groups over here and understand it further. What is the nature of the chart? How we can draw further deep analysis. But these will be the basics starting with. For deep, we have to go with multivariate, and then multivariate it's more than 2 columns now. So we'll insert 4 or 5 columns to check it out, how it works. So a lot of things are there. Let's stick to the basics first. So I have a office meeting now at 1:30. So I will be leaving today. Tomorrow, we are going to complete every stuff about it, starting with the analysis part. And I will ask the team to share the data set with also with all of you, as well as the Anaconda file also to all of you. If you can download it, then I can think you can all have a hands-on session with me from tomorrow onwards. So Indrani, subplot only helps you to split the entire chart area. The figure size will be same. In this figure, you like to have a single chart or multiple charts. That's what we can decide. So if it's a single chart, I can directly have a single chart over here. And if it's a multiple chart, I can define with the help of subplots. But you have to think at the back of your mind how many subplots you want. Whether you want 2 subplots in a single row, 2 columns format, whether you like to split the same area in 2 rows, 2 columns format, or like to split the entire area in the same using 3 subplots where 3 rows and single column is required. And then you just pass on the command that this first line should be mandatory, to which position number you like to highlight this entire chart. Thank you. I'm looking forward to connect you tomorrow also. My actually office meeting has started. Really sorry guys for today. I had unplanned activity. So I will connect with all of you tomorrow. Okay, I shared the drive link with all of you. Let us start our Jupyter notebook now. So on desktop, I have kept my file, that is webinar on data visualization. And yesterday we have gone with the flow, just a flow overview, how it is going to be there when you go for analysis of any data set using visualization. Today we are going to cover the charts and what all required for the skills. I will try my best that it is covered to the at most full extent as possible. Okay, so this was a data set given to us, and yesterday I have finished on analysis part. Today we are going to move with the analysis over here. What all you can perform with SNS? So we have using analysis univariate, exploring one column at a time. If it is a single numerical column, you go with a histogram or a bar chart. And if it is a categorical column, it's a count, bar, pie that shows the count of each values. We'll go first this type of analysis. Let us see the charts in that sector. So over here, I'm starting with day 2. day 1. So those who have my file, they can continue writing in the same file, and we can begin together. Okay. Day 2. So concern was if it is a univariate numerical column. Univariate numerical. What can you do for the univariate numerical? The syntax for Seaborn it's shared above. The chart name, plot, X label, Y label, and this thing what all you need to cover. So if I take a single numerical column, let's say INR, what type of chart we can have for this INR? Exploring single column at a time, numerical, histogram or bar. Even in Excel file, when you go to the insert recommended charts, over here you can see there is a line chart. This is actually a bar plot. It shows the range over here. Under this range, how many records are available. For example, how it looks. So if I take a random number between 1 to 20, okay, and I sorted. So these are random numbers that we have taken between 1 to 20, and you break it down into 4 range. That 1 is to 5, 1 is to 5. All of you have covered till class 10 this frequency. Under that frequency, how many, how to create bins. How all of you have done it. 6 to 10, 11 to 15, 16 to 20. You take 4 bins over there, and then you decide the numbers that fall in that. So this is the first bin. The second bin is 8 to 10. Only 2 elements are there. The third is these 4 elements are there. And finally, these are the elements that we have over here. And then we go with the bins. So it looks like this. All of you have covered such similar charts. We have taken 4 bins over here, and that is how the distribution comes up for numerical. That for these records that comes up, that is how a bins looks like. Is this clear? Clear to all of you? Kindly acknowledge in the chat box. Okay. It's the same distribution you like to see using Python, this Excel data. Actually, the main problem is that now Excel does not allow us for the easiness. And also, it does not allow us to change the bins over here, that how many bins you can have. And if the data is too huge, right now we have only thousands records. If it is go beyond 1,000 to lakhs, it becomes too slow. Same thing if you do in Excel, or sorry, Python, it will be a lot faster. So to make the distribution in the same fashion, you have a hist plot over here. And you write down the column name. So column name for us, let us import the packages again. Done. So my column name is price INR. Price INR. That is the column name. And X label, you can keep the X as price. Bhushan title is that's it. That's it. And check it out. So you can see the majority of the records over here is belonging to very close to zero. Very rare. The record was around 60,000 also. Okay, what is the mean? Mean is around 1454, and you can see clearly with the help of visualization also it's very close to zero. But comparison to the range of records that we started from minimum 0 up to 63,000, because of such higher range we are not able to get the proper information over here. So what you can do, you can change the bins also over here. So bins automatically taken. Bins is equal to, let's say, only 10 bins I require, and that is how the breakdown of the record has come up. So we have 0 to something 5,000, I think, that we have majority of the records. 10 bins are there. Now in 10 bins now the size is such that we are not able to see the distribution. There are some very small bins between 20,000 60,000 also. So it has distributed around, I think, up to 8,000, 0 to 8,000, and 8 into 10 80,000. I think between that they have broken it down, or 0 to 60,000, 60,000 to 6,000, sorry. So 6,000 to 10 60,000, between that they have broken it down. You can also change the color of it. Color, I like to keep the color as orange, and let's increase the size also of it. So plt.figure, I will increase the size of it. X-axis is price. Now comparison, when I see this figure, until unless I zoom up, then I think I can see over here distribution and price, but the font size is too small. You have the code to change the font size right in the label section, right in the labels. We call it as font size only. Actually, you can have other properties also, like you have your bold, italic, or underline. These font names and size, you can keep it up. I'm just picking font size. There are other parameters also, font dictionary. So I'm not going to deep into this one for now, only font size. Let us keep the X label as 14. Y as 14, and size of title as 18. And here you can now, I think, see it clearly. You can do italic bold also. Yeah, everything is a possibility over here. Just need to be a little good in the Python code. That's it. Is it clear? How to make the very first numerical analysis? Kindly acknowledge in the chat box. Very first numerical analysis. Great. Okay. The next is how to go with univariate categorical. So under categorical, when you pick up a column in Excel file, let's say gender I pick up. And I go with the insert recommended charts from the Excel point of view. Here is the data. So we can have a clear understanding that women have the maximum records. No, sorry, men have the maximum. Women have the maximum records over here. We have sorted it also. Women with the maximum one, and then men being the second highest, and then unisex, boys, girls that you can perform. Or you can select also from these categories in Excel file. Let us filter the records. You can do a little formatting here. Which chart, what type of chart you think is more appropriate. And you can add some axes also. So data labels I can ask. Data table, no. So these type of analysis you can do in Excel file. It is only and only for this gender. You can go for other columns also, like I have this primary color also available, and brand also there. So brand, I think there might be 100 brand, so I don't want to waste my time over there. Let's stick only and only on your gender first. So again, the format will be same. So I'm copying the above code. I'm sharing this code in chat box also. This will be used a lot. Now for univariate categorical, we have a Sevan count plot. We have a count plot for it under price, and we are going to put it for DF of gender. 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 So I'm just changing the name to gender, and the type of chart, we have a count plot over here. I run it, and here is the count plot. Okay. So clearly see, women being the highest one, men being the second one, and then so on. Later on, we will understand how to sort it also. That is also what you can perform. You can sort the data over here. And you can also change the orientation. We will pick up from the next column over here. Let's say primary color I pick up. For primary color, I like to change the orientation. So the primary color has a look and feel in this manner, blue being the highest one. All of you have seen in real world that blue is the highest purchased product. And then the black color. Do you wear a red color? I'm astonished over here. All of you agree, no? Blue and black in real world. You may see maximum products on e-commerce websites. Yes or no? So I'm looking forward to change the orientation. Instead of 525, I like to have 520. So, and in this figure, I like to change the orientation. So orient is equal to horizontal. Where I'm missing orient. Okay. So instead of x-axis, I like to keep my y-axis. And I've changed the orientation. So height is width. I like to take width is 20 by 20. Yeah. So I can see blue being the highest one, and then black. Later on, we will learn how to sort it also. Under multivariate, I will perform it. So kindly go with this on gender, or over here under the primary colors, we have description, brands also, product names also. There are many other columns are there. So next, this is a univariate analysis. Going with the next one, that is bivariate. Comparing two columns at a time, and I like to have numerical versus numerical. Numerical versus numerical. So I'll again copy the structure. So what are the numerical columns I have? I have only two numerical columns, that is price and actually images. And I don't think there is any correlation over here. No need to even understand. As a part of the structure, I'm explaining it, how to do with the numerical is numerical, but I don't think it will help you out. So x-axis, this is called as scatter plot. On x-axis, I like to have my number of images. On my y-axis, I like to keep my price INR. X label, and here is the chart. This font size you can also increase as per your requirement. So font size 14. You can run this code in any software. It is going to show you the output. And color, I like to keep it as magenta. So there are products which are having only two images and their prices of such products. What you learn from this graph? What is your conclusion or analysis on it? That if there are a number of two images of 1, 2, or 3, relatively for 2, we have a price range up to 10,000, 10 to 12,000 around, that I can see in the figure. And then there are 3 and 4 also available, where there are some very different records where the price is over 50,000 also. And there are very few images, very few products which are having only 10 images, very few. You like to see the results also for that, we can quickly run a query. So yesterday I mentioned that I will make some pandas queries side by side. So number of images greater than 10. Query is like filters in your Excel. So number of images is 10. Is my screen going black and white or color for all of you? Is the screen is black and white, gray, or is it color? Okay, then it's okay. I think by mistake I have clicked something. For me, it's a black and white picture coming up. Okay, so number of images more than 10. Only 3 records are there. I like to see the same analysis using pandas also. Number of images is equal to 10. So using this query, we can also see there are only 3 products, which and their price range is 7,000, around 6,000, 6,000. So there are 3 products in all. which are giving in, and all, I think pink, yellow, green, 3 different colors are there. 3 different colors over here. Okay. So that is some analysis you can also do side by side. So we have done bivariate analysis where we have seen this images and correlation, price scatter plot. You can also go with a correlation chart, guys, and that is with the help of SNS dot heat map gives you a correlation also between 2 columns. So I'm taking a 2 columns like this. I'm taking 2 columns only. The 2 column names are price and number of images dot correlation. You can have a correlation chart for also that, and we can see between number of images and your price INR, or let's see the annotation also side by side. And now, so only 0.13. What is correlation? Correlation is something like you like to study the analysis between two numerical. As X increases, Y also increases. Like height, weight increases, and here this is the correlation chart. Positive correlation, as X increases, Y increases. Negative correlation, X decreases, Y decreases, and zero correlation, that is stagnant. The points are very close to each other, and that's the same way you have to go with, guys, over here. It's little further deep end, don't worry today. So values are very close to 0, that is under 0.2, minus 0.02 to 0.2, if the values are there, then no correlation. So there's no correlation between price and number of images. Going with the bivariate analysis now. Under bivariate, here you find multiple charts. Here you will find multiple charts. SNS dot bivariate means if I have one numerical, one categorical, let's say primary color and number of price INR I have. So under Excel also, if you go to the insert and recommended charts, not coming. Oh, I got the point why it is not coming, because I have to make a pivot table for it. Let's make a pivot table. For each primary color, what type of price you like to take it up? Let's say I like to take up the average. As of now, sum is coming up, but you can take it as average also over here. This type of activity of making a pivot in Excel is with the help of group by in Python. And I like to make a chart for this. Now for this pivot, insert recommended charts. You can see the chart over here. We can have column, we can have pie chart over here that shows the variation. We can have bar chart over here with respect to price, all of you what we can have, and we can have other charts also. Let's go with the columns first. What we can see, that sum, that is total sum, we have accumulation of pair we have achieved for silver. Silver, we have achieved the highest accumulation. We are taking the average. So average price of the silver colored products available on the website is 2800, whereas the lowest is for the peach color. So that is the variation you are doing over here. But this is with respect to average. If I take instead of average as sum over here, by default sums comes up. If you put a chart, by default sums comes up in Python. So highest accumulation of all the products that we have is for the blue color. Then we have black color, and then red, and then white. I like to perform the same thing over here. So this type of chart is called as bar plot. bar plot. I like to keep on my x-axis. On my x-axis, I'm keeping the color, so primary color. On y-axis, I like to keep my price, so price. And same thing, on x-axis, I have my primary color. Y-axis, price distribution versus primary color. And this is the bar plot. This is the bar plot over here. And what you're seeing over here, this is the average chart you're getting in the Python. I'm saying that you can change over here. As you can change in Excel, you can have a change in your Python also. But for that, you have to have an understanding of group by. We are going to cover the group by today only in the multivariate. As of now, I'm holding. So just hold, take a pause for 20 minutes for it. So silver being the highest one, peach being the lowest one. And over here, you can see silver is the highest bar over here and peach being the lowest one. I think no, not like that. Let me give you a simple approach then later on. Stick the same chart. So what is this bar tell you and these straight lines, black color lines? Actually, these bar height is your mean or average. And the line, that black line you see on the screen, is equal to standard deviation. Some statistical terms which you will learn later on. So the black lines are the standard deviation. Okay, I can help you on one of them. Let's say first, I said red colored products. Let me see the spelling of red over here. Red. Total 1500 records we have for the red color. And red color you can see on the screen. Red or blue, what shall I keep it up? First, let's take the first color only, black. You can have a simple understanding over here. Black, 1600 records are there. And now for the 1600 records, I like to get the mean and standard deviation of this data set, where only the products I have black colored. So I like to get the price distribution for it. So red color, price. So can you see the mean is around 1960? And can you see on the chart also it's just below 2000? Visible to all of you? Great. And the standard deviation we have over here is 3297. So what happens? This 3297 is actually plus minus of it. Oh, so it is mean of something like this. So it is NP dot mean of red color price INR and plus minus standard deviation. I think standard deviation formula here, x minus nu ka whole square upon n, and the population of standard deviation x is this. Okay, how to explain it as of now? I think this chart you can help you out. So standard deviation is somewhere, you can check it out. It's plus minus of the distribution. It's equivalent on the left and right side. How much you're going with that. So that is why just leave the formula for today. Just have a chart analysis over here. That a standard deviation, what is present on the right side, the same size will be also present on the mean left side. So as per the chart over here, you can check it out for the same size line is above and the same size line is below also. So it shows the standard deviation distribution, but as of now, this is a statistical topic. So if I go deep, I will be deviating from the current topic. So kindly read it over here. So this is the distribution it tells you. The other distribution then we do over here is your box plot. So box plot over here gives you the outliers information. I think I can change the primary color to gender. So box plot gives you the outliers. This dot 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 you are seeing over here is the outliers. How the box plot is designed? So box plot has the various parameters. Has the parameters like lower whisker, upper whisker, median, 25 percentile, which is nothing but between 0 and median. What is the median? Between 0 to 50 percentile, what is the median? 75 percentile, between median to the highest number what we have in this column, what is the median? So these are the values I have. I have IQR something, which is equal to 75 percentile minus 25 percentile. And this lower whisker, which you also refer as minimum, this is equal to 25 percentile minus K IQR. And upper whisker is equal to 75 percentile plus K 1.5 times K IQR. That is the definition. So any record which is present below the lower whisker or above the upper whisker, they are the outliers, which is highlighted at dot 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 over here. Okay, these are different parts of the box plot. So any dot, any of these dots you are seeing on my screen, which is below this minimum, which is your lower whisker, or above maximum, that is upper whisker, they are known as outliers. I think they've written wrong formula over here. They have written wrong formula. Byju's, see the Byju's part. Completely wrong formula over here. It's Q3 plus 1.5 times. Yeah, Q3 plus 1.5 times of IQR. This is the formula. Q1, what is the Q1? Between minimum value and the median, what is the first quarter 25 percentile? That is the lower part of this box.
and upper part of this box is Q3. If you want to see it vertically, it looks like this. Minimum, first quartile, median, mean, it's not there in the box plot. Third quartile and maximum. These are the what we have in the over here. So there are many deep analyses over here under the bivariate. A lot of things you can cover it over this part. And now it depends on look and feel, which is giving you the better answer. Today you have box plot also, you have bar plot also, you have strip plot also. Just change the name over here. This is strip plot. What does the strip plot tells you? It gives you more good variations. So this is the variation it shows, where the number of dots, higher the dots, more are the number of records present. Lesser the dots, less number of records it's there. And then it shows the distribution, that from lower to upper, how the distribution looks. It is just depends on the look and feel, how you're looking forward and proceed. Okay. So this is all about bivariate. I'll come back to the pie chart because I have to teach group by. After group by, I'll come back to the pie chart. Now third one is multivariate. And that is multivariate. First cover numerical versus numerical, then I will teach categorical versus numerical. So numerical versus this categorical. We have already covered numerical versus numerical. This is the numerical versus numerical chart. Copy. Under the numerical versus numerical, the distribution was only between two columns, that is price and number of images. Now I'm looking forward. Can I insert no price and number of images are not changed? Okay. But between these two charts, can I have a third value which is not there in Excel? So it is done with the help of color only color. We call this as hue. I like to compare on the basis of this price and number of images on the basis of gender. Now you can see 6 different colors and 6 different color of dots are available over here. The legend shows the different colors for different unique values, and over here you can clearly see the colors that we have. Similarly, if I go with, and let's say gender are having the maximum, no? Is there anything else? The rest of them, they have many unique values available, only gender have less values. So I can compare with the help of gender. Next one is categorical versus numerical versus some other categorical. It's not hard and fast that you always have to pass gender here. You can pass your number of images also, another numerical. The only thing is the color is given on the basis of unique values. On the basis of unique values. The more unique values you have, the more color it is going to provide to you. And it will be becoming unnecessary once you will reach your limit. 4, 5, 10 unique colors you can see on the screen. But if you have 50 unique values, is it wise to go with 50 unique values or 100 unique values? What do you say? If I go with the number of images, there will be around thousands of records are there. So is it wise to go with 1000 unique colors to understand the further multivariate analysis? So we don't process with respect to that. Although there's nothing wrong in that, I keep the number of images as hue, and you will get this type of color shading. So with respect to number of images, 1 being the lightest one, 10 being the darkest one, you're getting all 10 unique colors. But as the number of colors, that is number of these values increases, numbers increases, there will be so many colors available. You will not be able to have an in-depth analysis. So lesser, better. So that is what we have under multivariate, numerical versus categorical.
In the same way, if I go with categorical versus number, using this chart, if you like to proceed, just pass a hue parameter here. Hue is equal to, okay, now there are again many colors available. Let's say this is primary color. I like to experience primary color with respect to gender. With respect to gender. So 15 or 16 primary colors are there, and we are going to focus on gender. Let it come, it will take some time. And here it is. So it is taking that much time because under color you have 20 records. So with these 20 records, 6 unique colors are coming out. 6 unique colors are coming out, and you can see 6 unique distributions. You can provide your analysis on it. Under bronze, for example, what type of colors you see? Is it for men, women? Can you tell me the names? What are the names coming up over here as per the colors what you see on the screen for bronze? What about this peach? Only single color I can see. What about for peach? Men. So that is how it makes the job easier. So using the color analysis, you can find out. But if you want to vote a Python analysis that is code for it, it will be something like this: df of, where my df of primary color, for example, is equal to peach. Let's say bronze. Primary color is equal to bronze. Spelling mistake. I think space is there. So only 3 records are there, and I can check it out. Women and men, only 2 colors are coming out. So you can write a code. That's not a problem. But it would be great to see the visual analysis. Now, what do you think eye catches fast? Is it this record or is it this chart? Table or chart? What do you think eye catch faster? Eye is able to catch faster when we do analysis with the help of visualization. That is why powerful visualization tools like Power BI from Microsoft, Tableau from Salesforce is coming into picture. So it provides a good analysis. And I think when you go ahead, get more appreciations in your career, people are looking forward to make presentations, and the presentation nothing but more charts, more eye-catching information. Okay. So that is a multivariate. So far, we have covered very basic charts. Going with the next phase of the charts. Are you all ready? Before I move to the next phase now, let me give you some interesting more information, because I have done an in-depth analysis on this chart data. So I asked you a few things like where people provide maximum information about the data set, about these informations. So let me first improve it. I take it as df1, df.copy. My data, taking a copy of it.
Actually, if you see only my data primary color, you can carefully see that they are having some unique colors, and each of the colors is having some spaces. Because of that, now I was not able to produce the charts. It was giving me some small mistakes, and I have to write the correct spellings for it. So what I am thinking of to remove the spaces from this strip. If I run this query, x.strip primary color x and x.strip, I think we have null values also available over here. That is why. Okay, there are null values also available over here. df dot my data dot so yes, primary color has null values also. That is why I was not able to convert that null value is a floating point category, that's data type, and we are not able to cover a strip of information. Strip is to remove the blank spaces. So if I have many blank spaces available on the string, there is a blank spaces available and there is some information available. So strip is going to remove the blank spaces from left and right side of the string. It is going to remove the blank spaces of left and right. This is equivalent to your Excel trim operation. Now to fill the null values, fill NA now you check it out. I will not have any null value inside it. Primary color, I have removed it. I have replaced that by others. And now if I try to remove the blank spaces from these names, it is done now. That is, if I check it out again, there are no blank spaces. So I like to put a query. What type of query? I'm looking forward to make a query. Is the information of primary color available in the description? Is that there are records available in my system where I can find primary color available in the description? All of you can see now that there are primary colors mentioned in the description also. One first word, mostly all of them. Visible to all of you? Using visualization, I cannot pass this query. This is a Python code. Only with the help of query, I can have this understanding. So I'm looking forward for my data. My data, the query is if I'm able to find primary color. So there is a loop required. Range till 0. Actually, my data shape give the rows and columns. I'm looking forward to put a loop on the row side, and I'm looking forward my count. I'm going to count the number of records. Count will be increased by 1. Under what scenario it is going to be increased by 1? It should be increased by 1 under the scenario if my data dot ilock, or you can use lock also. I, color name is primary color, is present using membership operator, my data dot log I description, if it is present in description or not. What is the int tells you? Int tells you whether an element is present inside a bigger sequence. So if I can write down my 25 is present inside my sequence, which is having 10, 120 minus 35, 50, 70 minus 40. So it will return false. But at the same time, when I will return here, if I have here 25 also, let's say 50 over here, then it returns true. So I'm looking forward, go one by one, that is pick up this record one, this entire record, then check for the second, third, fourth, fifth, sixth. So go one by one and check it out whether the color is present inside the description also. At that time, I'm going to increase my counter by 1. And then let's see count. So total 7,361 records are there. 7,361 records are there where my color is present inside the description. And what is the percentage of records are there? So the percentage we can get it by divide by dot shape 0, 0.58. Okay, only and only 0.58% of records are there which have mentioned colors in description. That means many people are not focusing of writing colors in the description. Percentage of records or percentage of products so when we have searched some Amazon or e-commerce website, Amazon or e-commerce website, and I was looking for men t-shirts. So many of the products we found out, this is the product information, a glimpse. Description comes up when you click on it. So what I find out, what I can find out, so over here, I think I'm not getting a useful result. Let us go with the product name. Whether primary color is present in the product name. Okay, there was 58%. Here it is 86%. Let me convert it. Round off by 2 and convert to percentage. %86 of records we have over there. And similarly, I'm looking forward. Do we have somewhere product brand also mentioned in the product name? How many records are there that have mentioned product brand also under the product? Sorry, product brand also under the product name. 98% of records. Over 98.95. That is hardly 1% of records are there that doesn't think that it's good to include product brand name under the product title. Only 1%. So we have to help those 1% of people. Let us see for gender also. Do people look forward for gender right in the title? So I think yes. Majority of the records, 80% of the records, write down the gender also in the product name. So I think it's a wise decision to write down gender, to write down the primary color, as well as primary color, gender, in product name. Is it clear? the further analysis that I have done. Now we will understand how to make group buys that can help me make the pivot charts you are seeing on the screen. Group buy. The syntax is you write down the data frame name dot group by. In the bracket you mention the column name. After that you use the dot egg function and tell us the value. So for example, I take this pivot again. I've taken the pivot. Now over here I'm looking forward for gender, price. This is the pivot table. In this pivot table, I can see gender and the sum of price, sum of products, sum of price products that have been placed in each gender category. I'm looking forward for total number of records also. So gender, I can go with values. I get total number of records. I get the price. I can also convert this price to average. What is the average number of images that are placed in all of them? So this information if you want to have. So under group by egg function, write down the column name. Okay, what you think should be the new column name is equal to existing column name and the attribute. And the attribute. And you follow the same syntax for all of them. Let us demonstrate over here what type of group I'm looking forward first. This is a gender group I have done. Let's say this is a gender group. Is equal to df dot group by. The column name is gender. I'm looking forward for dot egg function and the column name. The new column name for me is total records. That is equal to the same thing I've taken. The same thing I've taken gender. Any column, in fact, you can take it up over here, gender. And I'm looking forward for a size of it. The next column is average price. So average price. Mean. And then we have average images. So existing column name was images, num images. And I'm looking forward to perform the task of again mean. That is the gender group I have. This is the gender group I was able to create using the group by function. That is pivot table is showing over here. Is it clear? How to make groups? And it's not only you can have 3 parameters, you can have n number of parameter guys. Let's say maximum price I like to also see. Attribute is max. So it is maximum price. So under women, the maximum price product is 56,000, while in unisex actually, and I think unisex male female. So there is 63,000 product, 63,000 price product. That is the maximum. So you can have such image information available over here. Now you want to plot it. You can plot this gender group. So you can see it is also a data frame. The gender group I have placed, but it's not a group or some other different data type. It is also a data frame. And since it is a data frame, I can make the same activity I was doing above for visualization. That is, now for this data frame, my index is gender. This gender is the index. So I can write down gender group dot index. And to get the values from it, to get the values, I use dot values function. It will only return the values, this sequence. Only this sequence it is returning. It is written arrays, but it's only the sequence it is returning. So I can write down at 0, 1, 2, 3. At position number 3, 0, 1, 2, 3, unisex is there. And here is the unisex. So I'm just extracting the value of one-dimensional sequence from here, and I can do the indexing, slicing type operations. If I have to access any column, I can write down gender group, that column name. So for me, it's average price. Here's the average price. And if I write average price dot values, you will only get the values sequence over here. This is what we have to plot. On x-axis, I will keep the values index names. On the y-axis, I will keep the price values. I can refer the same thing by another format, which you might know or might not know. It's okay. I don't know about it as of now. I can even consider this as a variable name. The columns names, the column name, if it does not have space between them, we can consider that as variables also, and it will give the same answer. So under index, I will take the values and I will plot it on x-axis. Under price, I will take the values and put it on y-axis. Combining all these activity, we'll be able to create the charts. Since there are 4 columns over here, I am thinking of making a subplot, and for subplot, I will giving in such a way that I can do a group sorting also. So I was saying that I will teach you group sorting. So we have sort values function for your data frame. Under that, you can pass on the column name. So new column name for this data frame. Let's say it's total records. And we have sorted in the ascending order. Or you can keep ascending as false. You will get in the descending order. So you can sort it also. So I'm going to create 4 charts. For each chart, I will sort with respect to that column name. And we'll repeat this activity. I think this will be the best code. I can give it to you by the session end. Let's understand again what I'm doing over here. This is a gender group given to us. In the gender group, I have 1 index column, 4 numerical columns. I like to have 4 subplots describing this information. So I'm going to increase the figure size first of all. In this figure size, I am talking about 4 plots. So let's take it as 6 only. I will try to make all the plots in a single row. So subplot, 1 row, 4 columns, first position. Second, third, fourth. So as first position total records, second average price, third average images, fourth maximum price. Under the first one, I'm looking forward for SNS dot. 1 is numerical. So all are numerical versus categorical. I can have a simple bar plot or pie chart also. You can have pie chart. Sorry. In SNS, you don't have pie chart. In actually PLT, you have a pie chart. Matplotlib, we have a pie chart. Okay, I'll come back to the pie chart later on. Let's stick to the bar plot only. Bar plot. Now I like to have a bar plot. Let me try it first for one of them. PLT dot bar. What I have for bar X and height. X, I like to keep my gender group. Gender group over here in the first sentence, I am looking forward to sort with respect to total records. And ascending is equal to false. I'm saving it to gender group. And in this gender group, I'm looking forward to take the index value on the x-axis and take it values. On the y or height, I'm looking forward to have the gender group dot total records dot values. Color, 6 colors are there. So I'm keeping the colors as manually writing out as of now, blue, orange, although it's not recommended, but I'm just doing the hard work for now. So yeah, this is the way how I was looking forward. So gender group I have taken ascending as false on the basis of total records. So total records you can see over here. And what else extra information I like to have? I like to keep the X label also. X label, so I think it's common for all of them. No need. Only Y label I'm thinking of Y label. And PLT dot title. You can have title for all of them. All different charts are there because. So distribution. The total record distribution, and on the left side I have total records. And you can have super title also. So you have to plot it above super title. So I'm looking forward for analysis of gender group. And increase the font size for the super title also, font 20. This is the distribution I'm looking forward. 10. So I've just changed the orientation of names on the x-axis so that it's clearly visible which gender group and which name is mentioned. There should be no overlapping. There's already a chart limitation for me, space limitation. Only one subplot. For the first subplot I've done. Is it clear what all measures I have passed over here for the very first subplot? Yes, according to 4 columns, right? I hope it is clear to all of you which how I have done with the very first subplot. I'm going to repeat the task for the others also. All of you kindly acknowledge. You will have this code here. Don't ask again and again. Great. Copy the code to the other. So here I am copy the code to the other and over here. So in the second subplot, we are comparing with respect to average image price. So first sort the values over here with respect to average price and over here average price. Average price. Then we have average images. So I'm going to sort the third subplot on the basis of average images. And the last one is the maximum price. And done. So there are 4 charts analysis in front of you for the gender group, and I have completed this part like all numerical analysis against the gender. So women had the highest number of records, and whereas average price distribution. So in unisex we have the highest average price distribution, whereas boys being the minimum. This means average price distribution. There can be prices low and high, but the number of records are quite low for unisex, whereas number of records for boys are quite high. Basis on that, number of images which was not useful, but we still we can see for men category 5 images are kept, whereas for unisex kids, boys and girls, it's 4, approximately 4, but still not useful information. Maximum price. So we have maximum price purchase for the adults only. Unisex, men, women come under adults. Whereas for children, so you can see such a high barrier. It's below 10K, below 5,000, I think. People are buying the products for unisex kids, boys or girls. Is that clear to all of you? You can repeat this activity for any other categoricals. Pick up anything now, and you want to have over here instead of gender, price, color, price, you can keep that also. This primary color you can also have. Since primary color has many records available, so what I can do for primary color is to pick up the first 5 top 5 names always. Top 5 names always for the primary color. So for that, how can I do it? This is the color group I'm saying. That is how the color group looks. I'm looking forward to just read the first 5. These top 5 only. So I'm going to save the results in color group. You can take top 6 also, but on the basis of what? That's the problem. Na? So I cannot do over here. We have to keep all the records, and I'm going to, when in the chart I'm going to plot, I have to do the slicing operation. So first of all, the name, change the color group over here. In this color group, I'm looking forward for top 5 records. So whenever total records are done in descending order, I like to keep over here top 5 records. Only 5 values to compare. On the basis of average price, only get 5 values. Because of my space limitation, I am concentrating only on top 5 values every time. And here is the result. So on the basis of colors also, you can have the top 5 records. Is that clear? You can also speak, guys. So I hope you like the way how we have to perform. All of you satisfied with this way? In the classes, we have a more in detail. I have not even scratched the surface of it. So actual challenge comes up when you do the complete data analysis using Python, pandas, and data visualization. There are a lot of still charts pending, but it will not be taken up till you have some experience. How to change some format, add some extra information. So from my side, I'll give you a demonstration how to do univariate, bivariate, and multivariate analysis. I hope it helps you in the best way possible out there in the tough market situation. But still a lot of things, again, I'm saying, a lot of things are being pending. Like box plot is there. Similarly, there are other charts also available. We have not done the depth of it. So that can be done later on, I think, if you go for other sessions where we can take it up your data analysis, if I will take the same data set. But that's all for these 2 days. If you have any questions, you can please ask. The pie chart. Okay, I will show the pie chart for one of them. Let me again share it. So pie chart, again, what's a pie chart? If I take a pivot table for this particular data, and you have a gender, and you like to keep the number of records over here, you can have a pie chart for it. This is the pie chart that shows the count of records. What else you can have? I can also go with average price over here and get average. And if I like to have the chart over here, let's say in these 2 columns, price and labor, this will change. So remove the count. Now this is the new chart that you have, average price one. Now how to do the same thing? I have already created a gender group over here. On the basis of this gender group, we'll pick one of them. Pie chart cannot be done without the pivot in Excel. Similarly, a pie chart cannot be done in Excel without the group by. You have to have some group. Over here, I have to take help from the plt.py. The attributes that we have over here is X, that shows what is the numerical value. And then you have labels, that is actually your categorical. So my labels is equal to gender group dot index dot values. My X is equal to gender group dot any of the column name, you can pick it up. Let's say average price, I keep up dot values. And here is the pie chart for it. In pie chart, you don't have X and Y label. You don't have X and Y level in the pie chart. So it's not good way to write it down. And let's increase the size also of it. Ten is to 8. And what else you can add? You can have a shading also over here, shadow, to give a slightly more visual look appearance that it looks pretty cool. And what else you can have? You can explode the slice of it. Explode means getting a slice of this pie outside. Now this explode with respect to the different values you have over here. Carefully see the position numbers. Boys, girls, men, unisex kids or women. Which section you like to keep above? You should know the position number of it. And between 0 to 1, you have to perform the exploding of it. How it works? So suppose I like to just keep men and boys outside. Boys and men. So 0.2 for boys, girls 0, men 0.3, 0, 0, and last for women also 0. And you have exploded the slice of it. So men was as 0.3, third position you can see. And boys was first one. So this is how you have broken it down. That is how you can make a pie chart for all the values, average price, then you have your number of images and that all. And we have an auto PCT that actually helps you gives you the distribution in terms of percentage. Though we have average price, if we talk about the total average price of the entire records we have, highest belongs to men. Second is women. And similarly, I think highest belongs to this unisex category. Okay. So with this way, you can have auto PCT, but you can show the numbers also over here. It's little more tough. I don't remember the code now, but you can have it. It's little more tough. Okay. Is that clear? So what visualization suits you best? You are the best developer. You have to tell the team what you have learned, what all analysis you have drawn. So make sure you take the team in the right direction. It's only on you. So that's for all for the data visualization using Python C1 package and Matplotlib. Any questions you have, please ask. You can unmute yourself and ask.
Hello, Anand here.
Yes, Anand.
Yeah, so just one question. Like you are showing the pie chart. So is it possible in data visualization, like can we do in like animated mode? Like suppose like there are multiple sections, okay, boys, girls, and like suppose the first it will show the boys, and after completing that, it will come to the girls like that. Can we possible? Can we have possibility in data visualization?
Using Plotly. There's
Yeah.
a different package that gives you
Yeah.
enhanced analysis.
Okay.
Anyone else? Okay, guys, then that's it from my side. Now Karishma from the LearnBit team will take it over. And thank you everyone and take care.